Another question at the end I want to pose is, if you have a way of sonifying information, materials information like proteins, how would a singularity sound like? And how would a fracture sound like if you were to use the analytical solution of a stress field, a singularity, to create sound? So what you're listening to here now is an audio representation where we use the knowledge of the stresses or forces near crack. Near crack, this is again the picture of the crack, we have the singularity, meaning that the forces become very large as you go closer to the crack tip. And the way we sonify this, the way we make it audible, is in the following way. We use a sine wave or a sound signal, and with the initial sound signal, which reflects the undeformed state between atoms, so basically having an equilibrium. Remember we had in the beginning, we talked about atoms being connected by springs. So these springs kind of actually look like sine waves, but this is an actual sine wave playing. And we then have forces acting on the atoms, right? So just like in atoms, if the forces are compressive, the atoms are going to be squeezed together. And if the forces are tensile, the atoms are going to be pulled apart. And we're doing the same thing for the sine waves. And what you hear in the audio is me moving around in the space around the crack. So I'm basically moving around near the singularity. And as I get closer to the crack tip, the sound is going to be distorted because I'm playing an original sine wave and I'm playing a sine wave that's slightly elongated or slightly compressed. And that gives a very unique audible signal, very unique audible information that you can hear in the background. And this is yet another kind of musical instrument you can use. And it's a way of understanding what it means to be near singularity. And it means you as a human can actually begin to experience the stresses and forces near a moving crack.